Hello, everyone, and welcome to today's webcast, Offload the Data Warehouse in the Age of Hadoop. Our presenters for today's event are Santosh Shiitake, Vice President of Products at Affluent, and Steve Totman, Director of Strategy at SyncSort. Together, Santosh and Steve have more than 30 years of experience in data integration and enterprise software, spanning product management, strategy, and business development roles. Before we begin, I'd like to review some quick housekeeping items. The presentation is scheduled to last approximately 45 minutes and will be followed by a live Q&A session. You can submit your questions at any time using the Ask a Question box on the left side of your player. Please also use this feature to request any technical assistance you might need, and we'll get back to you immediately. Also, you can download a copy of today's slides in the Event Resources tab in the lower left corner of your screen. After Q&A, we will do our live drawing for the American Express gift card, so be sure to stay till the end, and good luck. So without further ado, I will turn the event over to Steve so we can get started. Steve?
Thanks a lot, Jennifer. So hi, everyone, and welcome to the webinar. We actually have a very good turnout today. There's a lot of interest, so we'll try and be prompt. So back when I started my career in data warehousing in the 90s, this is the vision that the business had. For the first time, an enterprise data warehouse would bring together data from every different system and create a single source of trusted information. Data would be extracted, transformed, and loaded into the warehouse using ETL tools. These would be used instead of hand-coded SQL or COBOL and other scripts because they would provide a graphical user interface that allowed anyone to develop flows without needing rocket scientists. Automatic scalability to handle the growing data volumes. Metadata to enable reuse, governance, and sharing. And out-of-the-box connectivity to all the different sources and targets. ETL would then be used to move the data from the enterprise data warehouse to marts and finally delivered to reporting tools. This really would be information nirvana. So here's the reality of data warehousing today. As one customer recently described it to me, and I'm not going to try and do his American accent, but their data warehouse has become like a huge oil tanker, expensive, slow-moving, and incredibly difficult to change direction. Because of big data and growth in the 3 Vs, but especially volume, the majority of commercial and open source ETL tools are unable to handle the processing within the batch windows. As a result, the only engine people thought could handle the data volumes were the database engines, thanks to their optimizers. As a result, transformations were pushed into the source database, the target databases, and especially the enterprise data warehouse as hand-coded SQL or BTEC scripts. This so-called ELT, extract, load, then transform, meant that many ETL tools became little more than expensive and pretty useless schedulers. The explosion in usage of ELT resulted in a spaghetti-like architecture and became clearly visible to end users. If you go to any business user and ask them about their warehouse, a new report or the addition of a new column from the warehousing team involves an average of 6-month delay. So with so much hand-coded SQL, adding that new column is incredibly complex. It requires a modeler to add it to the enterprise data model, a DBA updates in the warehouse schema, then the ETL team has to update all the existing scripts, then you've got Q&A and regression testing, and ultimately SLAs are not just being missed, they get abandoned. So as you can see in the chart, as ELT has grown, end-user reporting and analytics have had to compete for valuable database resources like storage and processing. I want to be very clear here. Databases in SQL are great when you have the classic use case. Big data input, small result set. Think of the overlap in a Venn diagram. Exactly what you want to create an aggregated view in a reporting tool for the business. But databases in SQL are not good for ETL, where it's typically big data input, huge staging area, even bigger data output. And at first there was less contention as the analysts and business users ran queries during the day and ELT could be run overnight during the batch window. But as volumes increased, the batch runs started running into the day and even during the day. And many companies no longer have that golden 12 hours of that overnight window. It shrunk to under 8 hours or even less. Today, almost every company has to do more ELT than can fit into their overnight window. So they're always trying to catch up. Even weekends, which were originally used for catch-up, are now part of normal processing hours. And if a load fails, it can literally be months before they can recover. This creates the SQL tuning death spiral because you move your best resources to tuning the ELT to improve performance, and your less skilled resources hand code the new ELT, which then means you have to tune it by your best resources again. It's this death spiral down, every step of which hinders agility and increases cost.
Steve, you bring up excellent points on how the ELT processes are driving up data warehousing costs. Our experience in analyzing data usage at large organizations show that a significant amount of data is not being used, but is continuously loaded on a daily basis. So dormant data not only is taking up storage capacity, but the bigger impact is the processing capacity in terms of CPU and I/O that is wasted on running ELT on the data warehouse simply to load data that the business does not actively use. Of course, in many situations or in most situations, organizations are required by regulatory reasons or to maintain a history of data even if it's not being used. So the best approach here to significantly cut data warehousing costs is to do a couple of things. One, identify data that's not needed to be maintained and just eliminate those batch loads. And two, for data that's not being used but needs to be maintained, offload those ELT processes onto Hadoop and actively archive that unused data on Hadoop. This way, you can recover all the wasted capacity related to dormant data on your expensive data warehousing systems.
Thanks, Santosh. So just to summarize, there are 4 dimensions to this problem. First, you'll see that you're missing your SLAs, as ELT competes with end-user queries and analytics in the warehouse. Next, you'll see that the warehouse team implements a data retention window. This is because there's simply not enough space, and it's not cost-effective to store all the data people want in the warehouse. So instead of the entire history, you keep a rolling retention window, sometimes as small as a few days or weeks, but certainly months instead of the years people want. Third, on average today, it takes 6 months to add a new report or a column to the warehouse. Customers describe this as the onion effect, because each layer of ELT gets added because no one wants to change the layer beneath. But when you have to in order to add a column or add a report, it makes everyone involved cry. And then finally, you have the constant upgrade cycle. Because of data growth, the second you've completed an upgrade, you're already planning for the next one. But the tough thing is selling this to your CFO. Imagine you have to go and explain to the CFO, well, you need to spend another $3 million this quarter on the warehouse. And he says, why are we upgrading again? Didn't you just do that? And you have to explain, it's so the standard report that ran yesterday will still run tomorrow. That's not a good business case. They want new data, new analysis, new insight. They don't want to pay millions more for the same reports. So as we've discussed, there's a reality of what happens today in most data warehouses, the before seen here, where ETL and ELT in the database have become the norm. As Teradata remarked on a recent earnings call, they found that ETL consumes about 20 to 40% of the workload of their Teradata data warehouses, with some outliers above and below that range. They also admitted that some of that ETL workload being done on Teradata is a good candidate for moving to Hadoop. Now, I've been involved with ETL my entire career, so for over 15 years. I built 2 market-leading ETL tools, and in my experience, the ELT workload of most data warehouse databases is typically 40 to 60%. And most of the customers I talk to are looking to move up to 100% of that ELT into Hadoop. But even if you could just free up 20% of your EDW capacity, that still means you could postpone any major multi-million cost upgrade of Teradata, DB2, Oracle, etc. for a very, very long time, which would make your CFO extremely happy. So we're seeing more and more customers adopt an architecture where the data staging area, the dirty secret of every data warehouse, it's where the drop from data sources gets stored in case of a failure, and a lot of the heavy lifting as ELT occurs, gets migrated to an enterprise data hub on Hadoop, which then becomes a long-term data archive. A subset of the results are then moved to the existing data warehouse, now with much more capacity and without breaking any existing processes or workflows. Customers are also putting reporting tools like Tableau and ClickTech directly to both the enterprise data hub on Hadoop and the enterprise data warehouse to create an intelligent combined view of all data. Now, what's really interesting about ETL and ELT is that the workload tends to be very transformation intensive. sorts, joins, merges, aggregations, partitioning, compression, etc. But the 80-20 rule applies. 20% of your ETL and ELT is what consumes 80% of your batch window, resources, tuning, etc. So the screenshot on the right is actually from a real customer. They call this diagram the Battlestar Galactica Cylon mothership diagram, because if you look at it from a distance, they had it printed out on a wall, it actually looks like that. It's their nightly batch run, and every single box on this diagram is a Teradata ELT script with several thousand lines of code. So they actually found that 10% of their flows consume 90% of their batch window. So it's not that you have to migrate everything. You just start with the 20%, and you'll see a huge amount of benefit.
So, Steve, you just described the challenges that almost every large organization is currently facing. At the end of the day, the time and resources consumed by inefficient processes has significant tangible costs. But Hadoop is quickly becoming a disruptive technology that presents a tremendous opportunity for enterprises. The economics of Hadoop, when compared to the enterprise data warehouse today, is quite remarkable. Today, the cost of managing a terabyte on a data warehouse can vary from $15,000 on the low end to more than $80,000 of fully burdened costs per terabyte. So enterprises are finding that the cost on Hadoop can be 10 times less expensive than the data warehouse. So the question becomes, how can you take advantage of this opportunity, and where and how do you begin this process? Offload and SyncSort together have the complete solution you need. So before we go into the demonstration and discuss the solution in more detail, let's briefly introduce Offload and SyncSort. Offload is a software company whose mission is to transform the economics of big data and Hadoop. Offload is the only company today that can completely analyze how data is being used and then with that information, enable large enterprises across various vertical industries to reduce costs and optimize performance of your systems. So the flagship product of Offload is called Offload Visibility, and it's a software product which gives you the ability to assess and analyze expensive transformations and workloads, as well as identify unused data that can serve as the blueprint to begin the process of offloading your data warehouse to Hadoop. The product non-intrusively monitors and correlates users' application activity and ELT processes with data usage and the associated resource consumption. And it actually supports multiple platforms, including Teradata, Oracle/Exadata, DB2, Netezza, and even Hadoop.
So for those of you who don't know us, who's SyncSort? We're a leading big data company dedicated to help our customers to collect, process, and distribute extreme data volumes. We provide the fastest sort technology and the fastest data processing engine in the market. Most recently, we released the first truly integrated approach to extract, transform, and load data with Hadoop and in the cloud. Now, if you have a mainframe in your organization, you probably know SyncSort because today we run on nearly 50% of the world's mainframes. We're the most trusted and executed third-party software. But our customers have been using us for over 10 years to accelerate ETL and ELT processing. Our product has a unique optimizer, similar to a database SQL optimizer, designed specifically to accelerate ETL and ELT processing. And our customers deal with some of the largest and most sophisticated data volumes. That's the reason they've come to us, because we solve data problems that no one else can. So every organization today is trying to technically and yet economically build infrastructure to keep pace with the modern growth of big data by storing and managing it in a single system, regardless of its format. The name people are calling this is an enterprise data hub, and in most cases it's based on Hadoop. But to deliver on the business requirements for data, an enterprise data hub requires components to access, offload, and accelerate data, while also providing ETL, extract, transform, and load functionality. They want a graphical user interface, productivity that doesn't require a rocket scientist or a data scientist to achieve simple tasks. Keep those guys busy with the bigger questions. They cost too much, and they'll get bored. They want metadata for reuse, scalability without manual tuning, and complete enterprise-level security. SyncSort enables all this, whether you're running on Hadoop, cloud, mainframes, Unix, Windows, or Linux. And thanks to that unique patented transformation optimizer, can scale to any volume with no manual tuning.
Now that you know a little bit about Offload and SyncSort, let's look at the process for offloading the data warehouse. You begin with using Offload to identify expensive transformations as well as dormant data that are loaded unnecessarily into the warehouse. Once you've identified what can be offloaded, keeping in mind the 80-20 rule where you focus your efforts on identifying the 20% of processing/data that is impacting 80% of your capacity constraints, you can use SyncSort to rewrite the expensive transformations in DMXH on Hadoop before loading the data into your data warehouse. You can also move the dormant data to Hadoop and use the DMXH for transforming and loading this data if you need to keep updating and maintaining unused data. This way you can eliminate all of the ELT related to unused data from the data warehouse and run it on Hadoop and store that data on Hadoop itself. Finally, this is typically not a one-time event. You should view Hadoop as an extension of your data warehouse, and they will coexist for the foreseeable future. So you can repeat this process continually to maximize performance and minimize costs of your overall infrastructure. So before we go into the demonstration of the solution, let's take a look at some of the features that Offload provides to get you started. The Offload software parses all the activity on your data warehouse at very granular levels of detail. This enables you to obtain actionable information using the Offload Visibility web app. So first, you can identify all of the ELT processes that are most expensive on your system that can be offloaded. Second, since all the SQL activity is parsed, you can identify unused data at a table and column level of granularity over specified time periods. Offload also parses the date functions being used to query data so you can assess the amount of history being queried by users, which can guide your data retention policies. And finally, in addition to expensive ELT transformations, you can also identify end-user workloads and associated data sets that can be run just as well on Hadoop, freeing up capacity on your data warehouse. So let's take a look at some real-world examples here. In this particular example that you see on your screen, Offload was used to identify expensive data extracts being performed by users running SaaS on a high-end data warehousing system. As you can see, the Offload Visibility web app was used to select applications that have the name SaaS and focus on workload that had no constraints, meaning only data extracts. What we found were SaaS was generated from 5 servers and just 42 unique SQL statements running repeatedly were consuming over 300 hours of server time. You can easily drill down on this information with Offload to find details such as what data sets were involved, which users were associated with this activity, so you get a full picture on it. So in this particular example, we actually found that this activity related to just 7 tables and was accessed by a handful of SaaS users, which we were able to pinpoint. So in this way, you could identify data sets to offload to Hadoop and redirect the application activity to Hadoop, enabling you to recover wasted data warehousing capacity. In the next example here, it shows you ELT transformations. In this case, the ELT processes only constituted less than 2% of the query workload, but was consuming over 60% of CPU and I/O capacity. Think about this queue for a moment. Offload can identify the most expensive ELT in this case by both resource consumption as well as complexity of ELT, meaning I want to look at ELT that by number of joins, by aggregations, by subqueries, and other inefficiencies so that you can actually focus your efforts on the ones that can give you the biggest bang for the buck to begin the offloading process. And lastly, I'm just going to show you an example here of identifying unused data. In this particular case, these large tables were not only unused, but they were continuously being loaded and updated on a daily basis, taking up wasted ELT processing capacity and unnecessary storage capacity as well. These 3 examples hopefully give you a brief glimpse of how Offload provides the first step in exposing relevant information that can be used as a blueprint to begin the offloading process. SyncSort will now discuss the next 2 steps in this process.
Thanks, Santosh. So the second stage in the framework for offloading data and workloads into Hadoop is the access and move piece. So once you've identified the data, you have to move it. While Hadoop provides a number of different utilities to move data, The reality is you'll need to use multiple different tools that don't have a GUI, so you'll end up manually coding all the scripts. And for many critical sources, for example, the mainframe, Hadoop offers no connectivity. There's actually already a really good question in the chat about this, which is, yeah, definitely the economics of Hadoop do seem lower, but there's definitely some limitations. And that's really where SyncSort comes into the picture. So SyncSort provides one tool, DMXH, that can access data regardless of where it resides. We have native connectors to Teradata, DB2, Oracle, mainframe, SQL Server, Cloud, Salesforce, etc. These connectors allow you to extract data and load it natively into each node of the Hadoop cluster, or load the data warehouse or marts directly in parallel. We also see a lot of customers pre-processing and compressing their data before loading Hadoop. One customer, Comscore, who loads 1.5 trillion events, that's about 40% of the internet page views, through SyncSort into Hadoop and Greenplum, saves terabytes of storage every month just by sorting the data prior to compression. So once the data is in Hadoop, you need an easy way to replicate the same workloads that previously ran in the data warehouse, so the ELT, typically sorts, joins, delta capture, CDC, aggregations, but now inside Hadoop. Sure, you can manually write tons of scripts with HiveQL, Pig, and Java, but that means you'll have to retrain a lot of your staff to scale the development process. But why reinvent the wheel? You can easily leverage your existing staff and skills. SyncSort helps you get results quickly and with minimal effort. We have an intuitive graphical user interface where you can create sophisticated data flows without writing a single line of code. You can even develop and test locally on Windows before deploying into Hadoop. In addition, we provide a set of use case accelerators for common ETL patterns like CDC, connectivity, aggregations, and others. So now let's see a quick demo of the solution.
In this brief demo, I'm going to focus on the 3 examples I just covered. So let me start with showing you how to identify unused data, and I'll finish up by showing you how to discover expensive transformations that can be offloaded using SyncSort. Now, to identify unused or dormant data, you can focus on analysis by data here, where you have the ability to assess your overall database or schema utilization, table utilization, or even column utilization specifically for tables that may have a large number of fields that are unnecessarily being loaded into your data warehouse. For this example, I'm just going to select table utilization here. When I do so, I'm prompted by a filter screen that you see here, which allows me to narrow down or to focus my analysis. So for example, I might look for activity for the last 3 months this way. I may also want to focus my analysis on some specific databases within my data warehouse. For example, I can select database name here, and I might pick these 2 databases of interest for me. And then I'll simply run this report. What I get back is an overall view of usage of data within those 2 databases that I just selected. For example, here you're saying that 48 tables are used, but over 1,000 tables are unused. Now I can simply drill down on this unused data to be able to identify what specific tables are dormant or unused. As you can see, I have a list of tables that come back to me, but they are rank ordered by the table size. You may notice that there are only 25 listed here. That's because that's the default, but you can change that at any time to get the complete list of unused or dormant tables. You'll also notice that the view resolution has been turned on. This means that we are resolving the views to the underlying objects so we can account for the tables that are referenced within views that may be created on your data warehouse. Now that you've taken a look at how to identify dormant data, let's take the next example of how to identify application activity and associated data sets that can be or should be offloaded to Hadoop rather than taking up unnecessary resources on your data warehouse. In this example, I'm going to select top applications to identify workloads or processes that are just doing simple data extracts that are being run on the data warehouse. So I have actually preset my filters called data extracts here, and allows me to identify applications. In this example, I said I want to look for applications that have the name CL tool associated with it. In your environment, it could be some other types of processes. It could have a name like SAS or other names and processes that you might be interested in. But the more important thing is I've also selected a filter called is constrained and turned it to be a no, which means that I'm only looking for activity where there are no constraints on the queries that are being submitted to the database, which means that they're doing simple data extracts without any constraints associated with it. And I'm ranking it by a metric that would be relevant here by the number of records being extracted or pulled back, which usually is indicative of the resources consumption on the system itself. So let me run this. What I will now get is all the application processes that are doing data extracts. In this example, I only get back one application name that has the word CL tool in it. But the information related to the queries being run are all simple data extracts. And what it's telling me is there are two statements being repetitively run that are pulling a lot of records back without any where clause associated with it, which means, as you can see here, more than almost 7 million records being pulled back. Now, Offload does a very good job of parsing this activity down to very granular levels of detail, so I can actually drill down on this process here to get more information about this activity. So this activity details for this process now allows me to identify who are the users that are doing these data extracts, what data sets are they actually pulling this data from, even the SQL statements, specific SQL statements being run without those where clauses associated with it. And we already know the application name, but if you didn't, you can actually identify the application processes that are actually the sources of that type of activity. So in this example, I'm just going to select data here, and then I want to identify the data sets that this activity is taking place against. So I can click on top tables if I'm interested in the tables here, and what I should get is the list of tables or data set that data extracts are occurring. Now, this example shows you how easy it is for you to do a quick analysis of a workload such as simple data extracts, map out the data sets to offload to Hadoop, and then since you can actually identify who those users are doing this type of activity, you can actually collaborate with the users to redirect their application activity and workloads to Hadoop because this is something that's better suited to be run on Hadoop without unnecessarily taking up a lot of resources on your production system. Finally, let's look at how you can easily identify expensive transformations such as ELT processes that can be offloaded to Hadoop. So in this example, I'm going to first identify what processes are doing ELT operations in the data warehouse. I have saved a filter set called ELT workload, and I'm just going to apply that. And you'll notice here that to identify processes that are doing some ELT, I've specified to look for insert statements that are associated with two or more joins. If joins are being done, more than likely transformations are occurring with those insert statements. So let me run this. So what I get is the processes that are doing some type of ELT operations. I only get one particular process here called ITETL here. In your environment, you may get one or more processes that could be doing ELT on your system. So now that I've identified it, I can now drill down on that particular application to get more details. So here now I can then identify who are the users that are running those operations or those transformations, what data sets are those transformations related to, and of course, more importantly for me here is which are the actual SQL statements that are being run that are particularly expensive as it relates to the transformations being done within the data warehouse and taking up unnecessary resources in the data warehouses. So when I select top SQL statements here, I should be able to identify the expensive SQL. As you can see, what I've got here is the list of the SQL statements related to the ELT. In addition to the inserts, I can actually view here, as you can see, you have the create tables, creating temp tables, dropping temp tables, as well as the inserts associated with the ELT process. What I can do here is actually reorder or rank the SQL statements by a metric such as, let's say, CPU time being consumed by the ELT processes. So the most expensive transformations are listed at the top, as based on this ranking. I'm also able to find the full SQL statement related to the ELT processes as well. And the nice thing is you can actually output those into a CSV file, as you can see on the right-hand side here, which can then be picked up by the SyncSort application, so that you can use SyncSort to convert these unnecessarily run ELT transformations that are taking up a lot of resources on your data warehouse using DMX-H. Now, SyncSort will now show you how you can convert your ELT that you've identified using Appfluent, that you can convert and run on Hadoop itself.
All right. Well, the Appfluent technology has shown us some processes which are really good candidates at converting from ELT to ETL. Now, how do we look at them? How do we understand the best way to put them into DM Express? Well, we have this great utility called SQL Analyzer, and it's designed to take that SQL code and make it more visual, so it's easier to see in the paradigm that we use here under SyncSort's technology. So take a look at one of the two we found. This one here happens to use a temp table and a few joins. The same thing, at least how we've designed it, is one that's all joins. So what we've done with this, we click our chart button to convert it into a chart so that we can visually see what's going on. We know all of the tables that we need. We know what we're joining to what and what we're joining on, as well as orders and grouping. Again, as a non-SQL programmer, this makes your life really easy because it makes a lot of sense. You know what fields and you know what you're trying to do. In fact, if you were to double-click on one of these, it'll actually tell you what we would be doing inside of DM Express. Now remember what this looks like. I'm going to now switch over and walk through the process under DM Express. Again, we haven't done any programming. We're not going to be doing any programming. A little bit of typing, but that's about it. So as we look at this, see what we have here. Walking through it, we have the database with one of our tables. We have all 4 of them. We're doing some aggregation to get our totals. We're streaming data through from process to process to do join, to join, to join. Makes sense. Now, the results of this are going to Hadoop, but if we actually wanted to run this on Hadoop, it's just a question of clicking on the section saying where do we separate the map side from the reduce side. We right-click, we say use map reduce sequence. So everything here to the left is being mapped, and everything here to the right is being reduced. Now, a little understanding of Hadoop makes it more efficient and keeps everything together, but the point is that I didn't have to do any Java or Pig or Hive or anything to design a MapReduce process, which is running natively, not interpreted, on your Hadoop system. So let's drill down a little bit. We're going to go take a look at what does an aggregate look like. Well, let's pull it up and see. So what we have here is we pulled our source from our database connection, and we've extracted these 2 columns. Pretty straightforward. To do an aggregate, I'm just going to click it up here. It's just a question of picking the right fields to do my group by. In this case, I want to do things by player, by year. And then I want to just give me a count for all the fields. So I want to know by player, by year, how many different, in this case it's awards, they have. All right. That being said, on output, you get to control the same amount. We picked our file in this case. When we choose the fields and the orders, it's really pretty easy. I'll just walk you through what I did by deleting everything. You just say, I want this field, put it to output. I want this field. I want this field. No select star statements, nothing that you're used to as a SQL programmer. It's just a lot of clicking. If I wanted to change the name, no alias commands. I could literally just call, and that's good to go. All right. So we've looked at an aggregate. we have 3 joins. Let's just look at the first one. So we look at our join. It's fundamentally the same thing. We have the output of that first one. That temp file is coming in. We grab the database and the necessary fields for the right side and define our join equally as easy as defining an aggregate. We say, on this side, I want these 2 fields, and their equivalent are these 2 fields. And if I make a mistake, it's supposed to be team ID. I just click on the value here. I click on the field. I just click the arrow to move it over. Now we'll be mapping this way. I found I made a mistake. Just as easy to put it back. Nice thing as well is we can output either just the match records or either side of the matched or unmatched records. So it makes it really, really nice. Very simple. And again, you're not programming. This means you get a lot more efficiency of designing it because, well, programming can be hard. Now, one of the nice things is that you can create new values on output, and you can do some very sophisticated things. So let me show you how this works. We create our value. We give it a name. We'll call this sample value. Now we have access to every field on both sources of data. Plus, we have a lot of really powerful built-in functions. Everything from conditionals based on which source it was, whether it joined or didn't, if then else's, conversion of data types, everything from date times to hashes, lookup tables, numeric information, source and target, so I know where things came from, a whole slew of text fields, and user-defined information. You can even have your own custom DLL function, or so that you can incorporate it into our technology. All right. So we've done our aggregate. We've done our first join. The second join is just like the first one, just on different fields. Let me go to the output because I want to point something out to you on this. So we're looking at our output, and you see here, now it's going to this HDFS because it's in fact going to a Hadoop file system. That is the target. For us, there's no difference between a database or a file or a Hadoop file. That's just the way the technology works. Now, of course, would I believe me? Of course not. So what I'm going to do is I'm going to pull up the VMware sessions. It's Cloudera. And you can see these are the results of that process I ran. In fact, here they are in order, exactly as available to you. So you can see that we've taken this as code, identified it this kind of as a visual so you can work with it better, converted it in individual components here, streaming together so you can see it more visually, to finally get, in the end, the data that you want.
I want to talk about a large financial organization we worked with and who found that their data growth and business needs had begun to grow at a rate that made it unsustainable to continue adding more capacity to their enterprise data warehouse. So once they determined that managing data on Hadoop would be more than 5 times cheaper than what it cost them on the data warehouse, they decided basically to cap the existing capacity on the data warehouse and implemented a strategy to deploy Hadoop to extend their data warehouse. So they started by putting together a data warehouse modernization project and then systematically began analyzing and identifying data sets and expensive transformations using Applant and offloaded to Cloudera. The result was that they successfully capped the existing capacity in the data warehouse. They estimated that if they had not done so, they would have had to spend in excess of $15 million on additional capacity over an 18-month period. Instead, the Hadoop environment, which is now an extension of their data warehouse, costs 6 to 8 times less in total cost of ownership per terabyte.
So this is another financial institution. It's actually one of the largest in the world. And the bank had a significant amount of data hosted and batch processed on Teradata. Now, Teradata excels at many things with this customer, but ELT was really driving costs up. So by offloading ELT to Hadoop, the customer could make better use of Teradata's great technology. So having heard about Hadoop and the significantly lower cost per terabyte, they decided to migrate a loan marketing application to Cloudera's distribution of Hadoop. So their warehouse team knows exactly, 42%, what proportion of their data warehouse is doing ELT. And while the first migration proved the viability and massive cost savings of the Hadoop platform, they have hundreds of applications they need to migrate. So this loan application they moved across was initially using Hive and HQL and resulted in meeting the SLA, but it had much slower performance and many maintainability concerns. So the bank sought tools that could leverage existing staff skills in ETL to facilitate the migration of the remaining applications and avoid the need to add significant staff with new skills, MapReduce, Java, Hive, Pig, etc. So the results really were staggering. Significantly less development time was required for the DMX-H implementation of this loan project. It was 12 man-weeks for HiveQL, 4 for DMX-H. This simplified process, so instead of 140 HiveQL scripts, it was replaced with 12 graphical, easy-to-maintain DMX-H jobs. And finally, they reduced processing time from 6 hours to 15 minutes, many times better than Hive, and it's actually even slightly faster than the original application in Teradata. So there are 3 key takeaways for everyone on this webinar. 1, you should be aware of the warehouse cost and capacity impacts from ELT and dormant data and the way it's going to impact your end users, and already is. 2, offloading ELT and unused data from your EDW to Hadoop has been proven as the lowest risk, highest return first project for your new Hadoop cluster. And the cost savings can justify further Hadoop investment and more moonshot-like projects. And it frees up those enterprise data warehouses to do what they were meant to do in the first place. It's 3 simple, proven steps: identify, access, and deploy. And finally, I just want to be very, very clear here. The enterprise data warehouse is not going away. However, it's about freeing up storage and processing capacity from these expensive platforms so you can repurpose this extra capacity for faster queries and analytics. By following these simple steps, you can really use an enterprise data hub based on Hadoop and your enterprise data warehouse together with the combined solution from SyncSort and Affluent to deliver something even better than the original vision of the enterprise data warehouse we talked about at the beginning. So today in the sticker packs you'll get from attending the webinar, there's an I Love Big Data and a Warehouse Warrior sticker. I hope you will wear them with pride.
Thanks, Steve. Before we go to Q&A, I want to bring everyone's attention to an exclusive offer we have for those participating today. You can go to the URL shown on the slide to qualify for a data warehouse assessment, during which Affluent software can be used to assess the potential for offloading expensive transformations and dormant data and develop a business case. We will leave the slide up while Jennifer will provide some instructions for the Q&A session that we will start in a moment here.
Great, thank you. So lots of great content and lots of great questions that are coming in. And just a reminder that if you'd like to submit a question, you can do so on the lower left-hand side of your player. Let me just pull up the first question. So this question actually is for Santosh. Does Affluent run an agent on servers or collect metadata information from other applications' metadata?
So Affluent does not run any agents on application side, but it actually runs a small agent on the data warehousing side, if it's depending on the platform you're running. Or if you do not want any agent running on your production system, we have the option to run what we call a collector that collects information from your data warehousing platforms to process and analyze and give you the information we showed.
Great, thank you. This next question, I'm not sure who it's for. Oh, it's for SyncSort. So in data offloading to Hadoop file system, is SyncSort, looks like, does SyncSort provide any data quality checks like record count, dedupe, watermarking, schema validation, etc.?
Yeah, so that's all basic ETL functionality that we include. I think what's really interesting is not only can you do that from the UI, we have a transformation language called DTL, which you can dynamically throw at the engine, and it'll generate this stuff on the fly. So I've seen customers that basically do all this on the fly. They'll pick up data, build the rules, and then just run it through the engine. So yes, absolutely.
Great. And this one, back to Santosh. In Appfluent, do we have any facility to alert application user/client for long-running queries, high memory usage/memory issues, or some other errors coming during ELT process via email alerting or on-call alerting?
Good question. Yes. In fact, we have the ability to set thresholds and get notified on any type of complex activity or resource consumption type of triggers. When I mean complex, it could be looking for ELT that, let's say, are doing more than 10 joins with 6 or more subqueries involved. All of that is fair game for the Appfluent product to analyze. So you can set up those thresholds, and when you see that type of activity, it can notify the right folks within the organization.
Great. And back to SyncSort. Hello, does DM Express replace the existing ELT process or tool, or does it overlay on top of it?
So I'll take that. So absolutely, we do both. So we see customers that actually will plug us in to supplement an existing tool. And if you're using something like DataStage or Informatica, we actually have utilities that will take the mappings and jobs and convert them into DMX. Certainly on off Hadoop, we're seeing a lot of that where people plug us in to kind of make their existing stuff go faster. What we're really seeing on Hadoop is that, we're probably one of the most mature tools out there. I mean, we've got a plugin directly integrated into the core framework. And, in that space, we're seeing that the requirements really do suit us perfectly. Very small footprint, high scalability, the auto-tuning in there as well. So Hadoop kind of gives us very strong parallel scalability when we provide the vertical scalability. So on Hadoop, we actually see a lot of vendors talking about it and having nice slides, but their software really isn't ready to run there yet, and that's proven out by the customers we see.
All right, great. This next question, I'm not sure who can answer it, but I'll throw it out to both of you. What kind of tool are you using for offloading the data? We are facing issues with throughput when extracting data to Hadoop HDFS. I'm not sure, Steve or Santosh, who would be better to answer that question.
So it was basically, sorry, could you repeat the last bit of it?
Absolutely. What kind of tool are you using for offloading the data? We are facing issues with throughput when extracting data to Hadoop HDFS.
Oh, so that's exactly what DMX does. I mean, we're really good at basically ripping data through, and we actually added a contribution to the core Apache framework, which Cloudera, Hortonworks, MapR have all picked up. That means we have this very low-level pipe straight into the framework. So if you're struggling with that, you should definitely come talk to us. And more importantly, that optimizer means that at 2 o'clock in the morning when this stuff starts, bottling up, the framework and the optimizer will kick in and balance it automatically for you. So perfect use case for us in DMX.
Great. This one is back to Appfluent. If I have a table that is 500 gigabytes in size and only 50% of the data is being accessed through primary index read, the other 50% is never used, will Appfluent report on this fact?
That probably requires a lot more a lengthy answer in terms of from a technical aspect, but the short answer is yes, we do parse all the information related to indexing of data and how the SQL is actually running against that data. So the short answer would be yes, but a more involved answer would take a lot of time, so we'll do that offline.
Okay, great. Again, I believe this is for both Appfluent and SyncSort. Which Hadoop distributions do you support?
Steve, you want to take that?
Yes, as I just mentioned, we're in the Apache core. We're also supported by Cloudera, Hortonworks, and MapR. So they've all picked up our plugin, which is great. And then there's other distributions constantly being added. So, and Santosh?
Yep, it's the same thing with Appfluent as well. So we're completely in sync.
Great. So this one is for Steve Topman. Do I have to have Hadoop to offload my ELT?
No, definitely not. I mean, it's a great platform for this sort of enterprise data hub, but we've been doing this ELT offload for 10 plus years. We've got customers that have been moving it to Windows, Linux, Unix for many years. So you don't have to have it, but it really does provide a very compelling use case. And if you're trying to sell it to the business, using Hadoop is a great way because all these execs are seeing articles on big data and Hadoop, so it's a great way of kind of pushing the project through.
Great. And for Santosh, and by the way, I think we'll have time to answer probably about 3 more questions, and then we'll do the drawing and we'll wrap up with some final housekeeping. But for Santosh, can Affluent tell me how far back my users are querying the data?
Yes, I presume the question is related to the history of information on or data within one or more tables. Yes, as part of the parsing, the Affluent product actually does a full semantic parse of date functions being used in queries, whether in a where clause or whether it's even being referenced against date dimension tables. So we can actually say, if you're keeping 10 years worth of history in a particular fact table, we can tell you that users are going back to only like 2.5 years, and the rest of it is not being queried.
Okay, great. Let's see. This one is also for Santosh. How long does it take to deploy Affluent?
Yeah, nothing runs really on the production system, and there's no changes needed on a production system, and it's very non-intrusive. So the actual install of the product is typically, in most cases, less than a day. So it may require a day to prep for with the right permissions and what have you, but the actual installation is typically less than 1 day.
Okay, great. We have another question here. This may have been addressed in the presentation, but it probably bears repeating because it came in a couple of different ways through different people. But though Hadoop's economics seem to be lower, there are other challenges like coding resources in Java, resource availability, and considering the amount of nature of data, this is not an easy task. So considering the amount and the nature of data, this is not an easy task.
Yeah, absolutely. I mean, that's exactly why we moved DMX-H onto Hadoop, because it means you can literally do that data flow process and not require any coding. You don't need Java skills, etc. And it's a graphical user interface. It's easy to maintain, and it scales. I mean, for example, that customer earlier, Comscore, they use us prior to Hadoop. They take all the feeds from their web logs, and they use us as a preprocessor to dedupe, and then Hadoop's like a downstream system from us. So we can handle that volume. So that's why we're such a good fit. And then on the Hadoop cluster, sitting on every node the way we do, you could literally take full advantage of that cluster without requiring a rocket scientist. Keep those data scientists doing the big thinking, and this mundane stuff like moving data around, etc., have less skilled resources doing it.
Excellent. Well, that is about all the time we have for question and answer period. If there are any that we did not get a chance to address on the line, then we will certainly follow up via the email that you used to register with. So before we end today's event, we want to announce the winner of today's drawing, and that is, and apologies for the pronunciation, but it's Jonathan Akoba, I believe is how you say it, from Kaiser Permanente. So congratulations, Jonathan. We'll be emailing you this afternoon and find out how we can get that gift card over to you. And we are just about at the top of the hour, so I'd like to thank you all for coming. And also, as a reminder, you can download today's slides from the Event Resources tab, and everyone who registered for the webcast will receive a link to the recording when it does become available. So thanks again, and have a great day.
Thanks a lot, guys. Bye.